There's my wife, Crystal. She said she didn't want to be in the video, so here we are. All right, so it says let f be the function defined by this, then it says find the average rate of change. So again, that word average is always either average slope or average value. This is average slope. So if I'm going to find average slope, I need the point at 0 and the point at pi. If I plug a 0 into here, e to the 0 is 1, cosine of 0 is 1, so I'll get 1. If I plug a pi in, we get e to the pi times negative 1, so negative e to the pi. So I'll get negative e to the pi minus 1 over pi, and that's the average slope. Part B says, what is the slope of the line tangent to the graph at x equals 3 pi over 2? So that's just a fancy way of asking for f prime of 3 pi over 2. There's JJ fighting Bella, making a lot of noise. But first I'm going to find f prime of x. So this is a product rule. So I got the derivative of the first is e to the x times cosine x, plus the first e to the x. The derivative of cosine is negative sine, so I'll go negative sine of x. Carly, I'm doing a little thing here real quick, okay? E to the 3 pi over 2 times cosine of 3 pi over 2 minus e to the 3 pi over 2 times sine of 3 pi over 2. So 3 pi over 2 is bottom of the unit circle, so cosine is 0 there, so this guy's gone. Sine is negative 1, so that'll make that positive, so I get e to the 3 pi over 2. Okay, part C says, find the absolute minimum value of f on this interval. So anytime I'm finding absolute max or absolute min, I need my candidates. Those are endpoints and critical points. So my endpoints are 0 and 2 pi, and absolute minimum is I'm looking for the smallest y value. Next, I need to set the derivative equal to 0, so I would factor out an e to the x, and then get cosine x minus sine of x. E to the x can only ever be positive, so cosine x minus sine of x, we're asking the first time cosine, or the times cosine x equals sine of x. If I'm on the unit circle, that's here and here. So that would be pi over 4 and 5 pi over 4. So I'm trying to find these values. I've already found when I plug a 0 in, I get out a 1. If I plug a 2 pi in, I get e to the 2 pi times cosine of 2 pi. Cosine of 2 pi is 1, so we'll get e to the 2 pi. If I plug a pi over 4 in, I get e to the pi over 4 times cosine of pi over 4, which is 1 over root 2 or root 2 over 2. I'm sure most of you remember it as root 2 over 2. So I get root 2 over 2, e to the pi over 4. The answer key will say 1 over root 2. They don't rationalize it. Your answer would be fine. If I plug a 5 pi over 4 in, I get e to the 5 pi over 4 times cosine of 5 pi over 4. So this would be negative root 2 over 2 e to the 5 pi over 4. And if they're looking for a minimum, I'd say safe bet. If you've only got one that is negative, you'll keep that one. So the minimum will be negative root 2 over 2, e to the 5 pi over 4 will be your absolute minimum. If you're justifying that answer, you can say these were the candidates, and that's the smallest y value. Simple enough justification. D says, let g be a differentiable function. We got g of pi over 2 equals 0. The graph of g prime, the derivative is shown here, and it says find this limit. Pretty much a guarantee if there's a limit in an FRQ that it's going to require L'Hopital's rule. So first I plug a pi over 2 into each of these, and I get 0 over 0. Just because it tells me this one, and I've already calculated, if I plug a 0 into, if I plug a pi over 2 into here, sorry, cosine of pi over 2 is 0, so I get 0 over 0. That's an indeterminate form, which means you can then take the derivative of the top, so that'd be f prime of x over g prime of x, and I can plug a pi over 2 into there. I've already done f prime of x. If I plug up, I'm going to think of it as this way. So if I plug a pi over 2 into there, I get e to the pi over 2 times cosine of pi over 2 is 0, sine of pi over 2 is 1, so I get negative e to the pi over 2. G prime of x is here, so g prime of x, g prime of pi over 2 is 2. So I get negative e to the pi over 2 over 2. L'Hopital's rule, again, if you get 0 over 0 or infinity over infinity, You could take the derivative of the top, derivative of the bottom, try again. If that didn't work, you could do it again and again and again until it worked at the end, as long as you kept getting indeterminate forms. All right, guys, thanks.